Download this code from codegib.com, link in the description below. Python Observing urllib3 Response Compression, a detailed tutorial. This tutorial delves into observing and understanding response compression when using urllib3, a powerful and flexible Python HTTP client library. We'll cover 1. What is response compression, why it matters for network efficiency. 2. How urllib3 handles compression * built-in support and configuration options. 3. Verifying compression in responses * examining headers and decompressed content. 4. Disabling/forcing compression * controlling urllib3's compression behavior. 5. Observing compression techniques, gzip, deflate, brotli identifying the algorithm used. 6. Code examples and practical scenarios * illustrative code demonstrating key concepts. 7. Troubleshooting compression issues * common problems and solutions. 8. Advanced topics * handling custom compression implementations. 1. What is response compression? Response compression is a technique used by web servers to reduce the size of HTTP responses before transmitting them to clients, like Python scripts using urllib3. This optimization leads to reduced bandwidth usage * smaller responses consume less network bandwidth. Faster page load times * for web browsers, smaller responses mean quicker rendering. Improved application performance * less data to download translates to faster processing and a better user experience. Lower server costs * reduced bandwidth usage can lead to lower server costs for high traffic applications. The server compresses the data using algorithms like gzip, deflate, or brotli before sending it over the network. The client, urllib3, in this case, then decompresses the received data to retrieve the original content. This compression/decompression process is transparent to the user once properly configured. 2. How urllib3 handles compression. urllib3 has built-in support for automatic response compression. By default, if the server indicates it can compress the response, using the content encoding header, urllib3 will automatically decompress the response before returning it to your code. Here's how it works. Request header, accept encoding * urllib3 automatically adds the accept encoding header to its outgoing HTTP requests. This header tells the server which compression algorithms the client, your script, supports. Common values include gzip, deflate, br. Response header, content encoding * the server, if it chooses to compress the response, adds the content encoding header to the HTTP response. This header specifies the compression algorithm used, example gzip, deflate, br. Automatic decompression * when urllib3 receives a response with a content encoding header, it automatically decompresses the content according to the specified algorithm. 3. Verifying compression in responses. To verify that compression is indeed happening, we can inspect the HTTP headers returned by the server and then compare the content length with the original uncompressed size. Explanation *************************************************************************************** urllib3.pool-manager, * creates a pool manager instance, which manages connection pooling for efficiency. URL equals https://hpbin.org/gzip * uses hpbin.org/gzip, which always returns a gzip response. You can also use other endpoints on hpbin.org like hpbin.org/deflate, hpbin.org/brotli or a web server that you know serves compressed content. Response equals http.request, get, URL, * makes a GET request to the specified URL. Asterisk response.headers asterisk this attribute is a dictionary-like object containing all the HTTP headers received in the response. Asterisk content underscore encoding equals response.headers.get, content encoding, asterisk retrieves the value of the content encoding header. If this header is present and contains a value like zip or deflate, it indicates that the response was compressed using that algorithm. Asterisk response.data asterisk this attribute contains the decompressed content of the response, as a bytes object. We decode it to a string. Asterisk original underscore length equals len, data.encode, UTF-8, asterisk calculates the size of the decompressed data in bytes. Asterisk compressed underscore length equals int, response.headers.get, content length, 0, asterisk tries to get the content length header. Sometimes servers send the length of the compressed data in this header. Asterisk comparison asterisk we compare original underscore length and compressed underscore length to see if compression was effective. Keep in mind the content length header might not always accurately reflect the compressed size. Important notes asterisk. Asterisk the hpben.org service is extremely useful for testing HTTP features like compression. Asterisk the responses.data attribute already contains the decompressed data, so we decode it directly. You don't need to manually decompress using gzip.decompress etc. unless you are explicitly working with compressed data streams or wish to verify/manipulate the compressed data directly, which is rarely needed. Asterisk some servers omit the content length header for compressed responses. 4. Disabling/forcing compression. While urllib3 handles compression automatically by default, you can control this behavior. Disabling compression asterisk. To disable compression, set the accept encoding header to an empty string. Important asterisk even if you disable compression on the client side, using accept encoding, some servers might still compress the response anyway. In this case, urllib3 will not automatically decompress the response because it assumes the client is handling the decompression. If you encounter this scenario, you'll need to manually decompress the response using appropriate libraries like gzip, zlib, or brotli. Forcing compression, less common. You can explicitly request a specific compression algorithm by setting the accept encoding header to the desired algorithm. However, the server is not obligated to use that algorithm. It will use whatever it deems appropriate or none at all. 5. Observing compression techniques, gzip, deflate, brotli. Let's modify the code to explicitly handle different compression types if automatic decompression is disabled or the server ignores the accept encoding header. Explanation asterisk. Asterisk zip.zip file, fileobj equals io.bytes io, response.data, mode equals rb.read, asterisk uses the gzip module to decompress gzip data. We create a bytes io object from response.data to treat it as a file-like object. Asterisk zlib.decompress, response.data, asterisk uses the zlib module to decompress deflate data. Note the ubits equals -15 parameter. This is often necessary because some deflate streams are actually raw deflate streams, without the zlib header. The -15 disables the header. The try/accept block attempts different decompress ions to handle possible variations. *brotli.decompress, response.data, * uses the brotli module to decompress brotli encoded data. You'll need to install the brotli package, pip install brotli. 6. Code examples and practical scenarios. Downloading a large file. Compression is particularly important when downloading large files. Working with APIs. Many APIs return data in compressed formats, especially JSON or XML. Web scraping compression can significantly speed up web scraping tasks. 7. Troubleshooting compression issues. *gzip.error, error -3 while decompressing data, invalid distance too far back. This error usually indicates that the deflate stream is corrupted or the urllib3 parameter for urllib.decompress is incorrect. Try different values for urllib3, example -15, 31, or check the server's configuration for issues. Module not found error, no module named brotli. This error means the brotli package is not installed. Install it using pip install brotli. Server does not respond with expected compression. The server might not support the compression algorithm you requested in the accept encoding header, or it might choose to not compress the response for other reasons. Check the server's documentation or configuration. Content encoding header is present, but data is not decompressing correctly. This is often a sign of incorrect decompression logic or a corrupted compressed stream. Make sure you're using the correct decompression algorithm, gzip, deflate, brotli, and that the data is not truncated or altered during transmission. Weird characters in decompressed output. The decompressed data might not be encoded in UTF-8. Try other encodings like Latin 1, ASCII, or inspect the content type header for the correct encoding. Read timeout error, max retry error. While these aren't directly compression related, large compressed responses can sometimes exacerbate timeout issues. Increase urllib3's timeout settings if necessary. 8. Advanced topics. Custom compression implementations. While rare, some servers might use custom compression algorithms. In this case, you'll need to find or implement a Python library that supports that algorithm and manually decompress the data. Streaming compressed data. For extremely large compressed files, you can process the data in chunks as it is decompressed. This requires using the streaming capabilities of libraries like gzip or urllib. Key takeaways. urllib3 automatically handles response compression, gzip, deflate, brotli, by default. You can inspect the content encoding header to determine if compression was used. You can disable compression using the accept encoding header, but the server might still compress the response. When disabling automatic decompression, use the appropriate libraries, gzip, urllib, brotli, to decompress the data manually. #hpbin.org is a valuable resource for testing compression and other HTTP features. Understanding compression helps optimize network performance, reduce bandwidth usage, and improve application speed. This comprehensive tutorial should provide a strong foundation for working with response compression in urllib3. Remember to consult the urllib3 documentation and experiment with different scenarios to deepen your understanding. Good luck.